Alright, today we're going to do more with differential equations. That's what this chapter is about. So let's look at this differential equation. It says find the general solution of the differential equation. As we've done on other problems, we are going to separate the variables. This one's easiest separated by just cross multiplying. So when I cross multiply, I have all my y's on one side and my x's on the other. I'm ready to integrate. You must show that separation of variables for the AP exam. So we'll raise this by 1 and put that over 3. We can put plus c, but we're only going to add 1 plus c as it is. And then this problem, we're going to raise by 1, put it over that power, minus 3x, and there's the plus c. That's the constant, and this is the general solution because we were not given any bounds. So I end up getting 2y cubed equals 1/3 x cubed minus 3x plus c. Now most general solutions are not going to have any fractions in them, so I'm actually going to multiply everything times 3 to eliminate that fraction. And this is as far as I am going to take it. Lots of times we'll go ahead and solve for the y if it's easily solved. In this case, it's not as easily solved. Let's try another one. Here's that dy over dx, and so I'm going to rewrite this as x squared minus 16 to the 1/2 power dy over dx equals 11x. We're going to separate our variables. This one separates, I don't really have any y, so I'm just going to have dy. I'm going to have my 11x over here. I'm going to be dividing by the square root of x squared minus 16. And then I'll multiply each side by dx. So now that I've separated my variables, I'm ready to integrate. So y is equal to, this one's going to go ahead and require a u statement. I'm going to choose the bottom for my u. So my du ends up being 2x dx. Now, when I go to start writing this in terms of u, I have u to the 1/2 on the bottom. That takes care of this part. I needed an 11. I never got an 11, so I'm going to have to put an 11 out front. I need an x dx, and I have that. So I'll divide by 2 on both sides. So I have my x dx by itself. So there's my 1/2 now. I have 11/2 out front. And I have my du. So when I integrate, I'm really integrating u to the negative 1/2. I'll raise this by 1. And put it over that power, plus c. So I end up getting y equals 11, the square root of, and I just say 11 because 11 over 2 times this 2 over 1 cancels. U to the 1/2, that's the x squared, minus 16, and then I have plus c. On my next problem, it's asking me to find a particular solution that satisfies the initial condition. So this time I'm going to be able to find my c value. So I'm going to rewrite this as x to the 1/2 plus y to the 1/2 dy over dx equals 0. We need to get our variables separated. So I'm going to subtract x to the 1/2 off both sides. Then I'm going to multiply by dx on both sides. And now I'll be ready to integrate both sides. So then I'm getting y to the 3/2 over 3/2, which really makes it 2/3 out front, equals negative x to the 3/2 over 3/2, which really makes it 2/3 out front, plus c. Plug in this condition, 2/3 times 9 to the 3/2 equals negative 2/3, 1 to the 3/2 plus c. I will not get this finished in this video, so I'll pick this up in the next video. Alright, I said I was going to finish this up in this video, and I'm going to actually make a change. I want to go back to the step right here. I'm going to actually eliminate this part because there's one more thing I can do to simplify this. That would be divide each term by 2/3. So I end up getting a more simple general solution there. Now I'm going to plug in this condition. So I know that y is 9 and x is 1. So I end up saying the square root of 9, 3, and 3 cubed is 27. Square root of 1 is 1, and 1 cubed is negative 1, plus c. So my c ends up equaling 28. So now I can write my solution as y to the 3 halves plus x to the 3 halves equals 28. On this next problem, a little bit more complicated because it's going to be harder to separate these. dr over ds is equal to, we need to break those up. So this would be e to the r times e to the negative 2s. Now I can separate my variables. So I'll have dr over e to the r, divide off e to the r. And on the other side I have e to the negative 2s ds. I'm ready to integrate now. This really says e to the negative r dr equals e to the negative 2s ds. This integral ends up being an integral of e to the x is e to the x, but then you take and you'd have a u statement out of this, which would place the negative out front. This one would place a negative 1/2 out front when you create that u statement. And then you'd have your e to the u. It is asking you to use this condition. So you'd have e to the negative e to the 0 equals negative 1/2 e to the 0 plus c. That gives you negative 1 and negative 1/2 because e to the 0 is 1. Add 1/2 to both sides. You get c is negative 1/2. So the particular solution would be negative e to the negative r equals negative 1/2 e to the negative 2s plus negative 1/2. Now you could divide all those by a negative and come up with a little bit simpler problem. I'll see if I can squeeze this one in. So I have dy over dx is equal to negative 9x over 16y. That gives me 16y dy equals negative 9x dx. Integrate both sides. 16y squared over 2 equals negative 9x squared over 2 plus c. Multiply everything times 2. And then use your initial condition. Plug in 1 for your y and 1 for your x. You get 16 equals negative 9 plus c. So c ends up equaling 25. And our particular solution ends up being 16y squared equals negative. Alright, on this problem, it looks like we have different directions, but it's really asking us to do the same thing. It says, find the general solution to the slope field analytically. That means solve the differential. So we're going to separate our variables. So I multiplied by dx on both sides, and I'm going to divide by 4 minus y. This, you may want to make a use statement for. I'm going to go ahead and do it a little bit shorter way. So I know this is the ln of 4 minus y. When you create a use statement, you get a negative dx, and so you'd have to place a negative out front. This ends up equaling the integral of 1/4 x dx. So I have the ln, or negative ln, 4 minus y equals 1/4 x squared over 2 plus c. So the ln of 4 minus y is equal to negative 1/8 x squared plus c. Now, the next thing I can do is get rid of the ln by e'ing both sides. So that gives me 4 minus y equals e to the negative x squared over 8 plus c. So I have 4 minus y equals e to the negative x squared over 8 times e to the c. There's that big C again. So I've got big C e to the negative x squared over 8. And then what I can do is subtract 4. And then divide everything by a negative. Gives me 4 minus ce to the negative x squared over 8. Now, the back of the book will actually read this as 4 plus ce to the negative x squared over 8. The reason for that is because this big C can be positive or negative. So they'll just always put plus there because it could have been a minus negative 200 or it could have been a plus negative 200. So it really doesn't matter what sign goes between the two.